Hi, and welcome to Ella's Calculus YouTube channel. In this video, I'm going to review the definition of the average rate of change, how to determine the average rate of a change of a function over a given interval, how to find the equation of the secant line, and how to find the average rate of change in a real-world context. First, we can recall the rate of change. This is found using the formula y2 minus y1 over x2 minus x1, which equals the change in y over change in x, where change in y is dependent and change in x is independent. For example, take the 2 points 4, 20, and 3, negative 5. We can plug them into the formula to get negative 5 minus 20 over 3 minus 4, which equals negative 25 over negative 1, or 25. The average rate of change can be defined as the following. The continuous function f of x on the interval a, b has an average rate of change of f of b minus f of a over b minus a, where f of b is equal to y2 and f of a is equal to y1, or f of a minus f of b over a minus b. This is also the slope of the secant line. The purple line shown here is a secant line. A secant line is a linear approximate of a function between 2 points. The slope of a secant line represents the average rate of change of the function between 2 points. Let's go over some practice problems that become more familiar with the rate of change in use. Example 1 says, find the average rate of change of f of x equals x to the third minus 2x on the interval 1 over 2, 3 over 2. We can define 1/2 as a, or f of a, and 3 over 2 as b, or f of b, as relates to the average rate of change formula. Remember that the average rate of change is the slope of the secant line. The first step we should take is to plug 1/2 into the function as f of a equals 1/2 to the third minus 2 times 1/2, which equals negative 7 over 8. Now let's define f of b when we plug 3 over 2 into the function. F of b equals 3 over 2 to the third minus 2 times 3 over 2, which equals 3 over 8. Now we can use the average rate of change equation to plug f of b and f of a in. F of b minus f of a over b minus a is the equation. This is equal to 3 minus 8, 3 over 8 minus negative 7 over 8 over 3 over 2 minus 1 over 2, which is equal to 5 over 4 over 1, or 5 over 4. This number is the average rate of change of the function. Let's move on to a different example representing the slope of the secant line. We can also calculate the slope of the secant line, as we reviewed earlier, with the equation f of x plus h minus f of x over x plus h minus x, which equals f of x plus h minus f of x over h, with f of x plus h as y2 and f of x as y1, while x plus h is x squared and x is x1. In this example, we are asked to find the average rate of change for f of x equals x squared minus 4x plus 1 on the interval x plus h, where x is represented as a and x plus h is represented as b. First, we can plug in the values of the interval into the function in the equation as f of x plus h minus f of x over x plus h minus x, which is equal to x plus h squared minus 4x plus h plus 1 minus x squared minus 4x plus 1 over h. This is where f of x is substituted for the function as whole, as you can see with x plus h, x squared, negative 4x, from the equation x squared minus 4x plus 1. You can see the f of x here, and you can see the f of x plus h here. Foiling this equation gives us the resultant equation of x squared plus 2xh plus h squared minus 4x minus 4h plus 1 minus x squared plus 4x minus 1 over h, which is equal to 2xh plus h squared minus 4h over h. We can cancel out the h's, and that gives us 2x plus h minus 4. This is the final average rate of change for the function. And now let's look at finding the equation of the secant line that intersects the given points on the function. We are given the function y equals negative x squared plus x plus 2, with the given points negative 2, 4, negative 4, and 1, 2. We are given a parabola graph opening down, and we must find the equation of the secant line. First, let's calculate the slope, or the difference between the 2 points in the line. We can plot these points on the parabola and draw a rough estimate of the line, showing us the secant line on the parabola. Subtracting y2 minus y1 and x2 minus x1 yields 2 minus negative 4 over 1 minus negative 2, which equals a slope of 2. Now we can plug our known values into the point slope formula, which we have used in previous lessons to find the equation of a line. The point slope formula is equal to y minus y1 equals m parentheses x minus x1, where m is the slope. Let's plug in our known values, y1, the slope of the line, and x1. This yields y minus negative 4 equals 2 parentheses x minus negative 2. We can move the 4 to the other side of the equation, which effectively leaves us with no y-intercept for our parabola. Therefore, our equation of the second line is equal to y equals 2x. Let's look at one last average rate of change example. The cost of producing units of a certain item is C of x equals 2,000 plus 8.6x plus 0.5x squared. What is the average rate of change of C with respect to x when the level of production increases from x equals 30 to x equals 310 units? So first, we're going to plug this into the average rate of change equation, which is equal to f of b minus f of a over b minus a. And so we're going to plug in the values of x that they state. X equals 300, and x equals 310. So since 310 is equal to b, f of b, we're going to plug that in here. C of 310 minus c of 300, which is f of a, over b minus a, which is 310 minus 300 as the values. And that's going to equal 3,136 over 10, which is a simplified version of these functions. And then that simplified even more when you divide 3,136 divided by 10 is equal to $313.6 per unit. So that is the average rate of change. Thank you so much for watching my video, and I hope you continue to get support in AP Calc.